Hello YouTube, this is Sam from Tiger Schooling, and in this session of the video we're going to talk about the absorption, transport and mobilization of vitamin A. So in the case of absorption, we know that from the diet we take the vitamin A either as retinol esters from the animals and as beta carotene from the plants. So we have two forms of how we get in the diet, how we get vitamin A, either from the plants through beta, which is in the form of the beta carotene, and the diet, and the from animal sources we get is retinol esters. So the dietary retinol esters we know are actually hydrolyzed. I must mention over here that hydrolyzed, because retinol esters contain fatty acid. So what is retinol esters? It is actually retinol plus free fatty acid. So when retinol esters are hydrolyzed, they form free fatty acid. The free fatty acid is removed, and finally we get retinol, which is actually the vitamin A, you can say, or vitamin A alcohol. All right. So this is the case in the case of the retinol ester, which we take from the animals. But in the case of the plant, the diet, it has to follow a path. So in the case of the plant source, we get through the beta, which is the beta carotene, which are actually hydrolyzed. When the beta carotene is actually hydrolyzed, this is beta carotene, which is hydrolyzed by an enzyme which is called as beta carotene 15,15 dioxygenase. I would rather say beta. I won't mention C means carotene. You have to understand it. I'm not mentioning it. C means carotene. So beta carotene 15,15. All right, this is it. And dioxygenases. All right. This is how beta carotene is. We get from diet we get beta carotene, and beta carotene is actually hydrolyzed by beta carotene is 15,15 dioxygenase of intestinal cells to release 2 moles of retinol. We know that retinol is actually an aldehyde. So we get 2 moles of retinol from the beta carotene. So beta carotene contains 2 moles of the retinol. When breaking down, the beta carotene gives off 2 moles of the retinol, which further, when we get 2 moles of retinol, it can be converted to the retinol. The retinol, which is an aldehyde, can be converted to the retinol through reduction. So we can so what happened when through we get 2 moles of retinol, which is reduced to which is finally reduced to the retinol, as we have seen that in our previous video, that how it is converted through the process of reduction, because we know that from retinol we can get to the retinol through reduction, and because they are both interconvertible, we can get to retinol through a process called oxidation. So finally, from retinol we further move on towards the retinol ester, which is this one. Which is this one in this form. So how from beta carotene we are going to this form again. So what happens? We are going to or you can say esterify. Sorry about my spelling. It's kind of esterification. So in the intestinal nuclear cells, retinol is re-esterified to long-chain fatty acid in this form. Again, we are converting retinol by re-esterification and converted it into the retinol into the retinol esters. So long chain of fatty acid is attached to it, which is again, and this form is again actually incorporated, because without adding up the free fatty acid to it, without re-esterifying, we cannot incorporate the retinol into this form. So we have to convert it into the retinol ester, so it can be incorporated into the chylomicrons. So as we incorporate into chylomicrons, which are actually then transferred to lymph, and again from lymph they are stored in the liver. So here it is transferred through lymph and be stored in the liver.